time for the next talk. This is going to be about an evolution of our continuous integration for UEFI, Arm SystemReady compliant firmware that we do at Linaro. It's called Trusted Substrate. Its major architect is Ilias here. You most likely know him already from U-Boot and yeah, Arm SystemReady world. I'm Mikko, and Javier. We will present about the evolution of our CI setup a bit. Yeah, slide which Ilias explains will be a long one. Lots of slides, lots of talks, and yeah, we'll be reading it word by word. Hopefully not. Right. So I'm going to talk about the old CI that we had and some issues there, and which we then hopefully resolved in the new setup that we did, or that Ilias and Javier mostly did. So what we had in the old times was a build setup using the Linaro Tuk suite, which was building our Yocto-based environment and building a firmware and the operating system images for us there. We were managing the Yocto meta layers using the repo tool. So we had a bunch of, I think, half a dozen at least layers that we were cloning and managing the exact commits that we were using with repo. And we were able to build the full operating system and the firmware blobs, everything using the exact same commits of those meta layers. And manage transitions as well, like following the master branch, and when there's stuff broken, we can still have our stuff working. Yeah, then we had multiple repositories all linked together using the same, let's call it blueprint CI approach, where they were all using the same URL to download the GitLab YAML files. And then we were using the Linaro Squad service to trigger build and test runs in Linaro Lava setup. And the Squad is also collecting all the statistics and logs. This had a few other things. Yeah, as I said, we built multiple things, all the firmware for each of the devices that we support, then the operating system, which included a whole bunch of things. That meant that every build had a whole bunch of parallel jobs running. Yeah. Then we used Lava to test everything per board and run some tests, including capsule updates, secure boot, measured boot, and those included running the whole or booting into the whole operating system and then running the tests there. For actual or several of the testing steps, we relied on the U-Boot implementation of the command line interface there to capture the serial console output and then do some magic there. And yeah, we had test runs which were purely focused on the firmware, but then we also were doing, let's say, end-to-end testing with a real operating system built with Yocto. Now, this had some issues for us. First of all, our builds were quite long because we're also building a quite complex operating system, which included things like Docker. So to run some container and cloud readiness workloads as well. This meant that even with full Yocto state caching, our builds were at least 50 minutes long. That required full builds of the root file system, even when the cache hit rate was 100%. Yeah. Yeah. Then the flashing time in Lava, well, it was unfortunately quite long. The operating system ended up being, I think, close to 1 gigabyte in size, the root file system. And then we had some issues in the Lava because when we were triggering builds for the changes, multiple jobs in parallel were downloading the exact same files, and this caused some networking issues and cache issues and so on. So sometimes we had failures there. Then when we were flashing our various target devices, we usually used the so-called SDMux flashing approach. We first flashed the firmware and then the full operating system image, like 1 gigabyte in size, which was quite big. But on some devices where we did not flash the firmware, or we don't even build the firmware, we were using the vendor firmware, we were still using various approaches to flash the big image of the operating system there. And there we ended up using things like TFTP and weird network-based setups, which were sometimes prone to failures as well. Yeah. Then in the testing phase, we were utilizing basically the U-Boot command line interface a lot on most of the Lava targets, which meant that we were basically bound to a specific implementation of the UEFI standards. Yeah, more issues that we saw was that in Lava, squat triggered had some issues because of, I guess, high load on our server with all the statistics that were gathered and so on. So over the years, things became more slower, and then we had several hours until we got results from our Lava test runs. Then, of course, also for the UEFI testing, we were doing end-to-end testing with the full operating system, so it required a full boot of the operating system, which in some cases took quite a while. And especially because we were also testing real TPM devices, or also firmware TPM devices, and if that setup was working in the firmware, then we also used it in the operating system to re-encrypt the full recently flashed operating system partition with the TPM device. Yeah, and yeah, these were combined in the multiple jobs and lots of interactions, which were not exactly easy to always write in the Lava test job definitions. So lots of different command line prompts which needed to be detected and so on. Yeah, so here is a sort of a sequence diagram of our developer's view to the system. So basically we had an open merge request in a Git repo. We would use the tag suite to build all the different targets with Yocto, which is reasonably fast, and I guess using Amazon Cloud Services for that, with state caching and download caching as well. And then once we have the results, we would download them into GitLab and upload part of the results into Linaro Squad. Then we would use the Squad service to trigger Lava jobs for testing purposes. And in the end, the results come back into the merge request that the developer triggered. Pass or fail. Yeah, so then we go to a new iteration, which changes a bunch of things, and Javier will take over and explain the details there.
Thank you, Mikko. Okay, so yeah, with the new CI, we migrated to using GitLab pipelines, and now we have a new server, and this is the first server running a native Arm 64 machine, very fast actually. We configure this machine. We integrated. GitLab has a very good integration with the machine. It's pretty easy to do it. And so, so we did all the flashing per board using the ESP partition, the EFI partition system. And only we did one build for per variant per board. And then we created we recreated the same test for EFI, but this time, and the great difference the Elias did was to create a small EFI application. This application was implemented castle update, UEFI secure boot, master boot, and then launcher the OS from the RAM, and this is a very new feature because the main difference is compared to the old CI was the OS was running on the RAM all the time, so no, it was not flashing in the storage like a SD card or MMC. So with this, we have a very simplified U-boot CLI, and the same test that we were running in U-boot before, we're using now ADK2. This is a big difference. And all these tests was running in the using operating system live image, and this is well, the live image should be is limited because we have a constraint in the memory RAM, the limit the 2 runs. So we have several OS running inside of that limit of 2 gigabytes RAM. Sorry. The bit different, as you remember before, this was running until around the 4 hours to finish all the tests, the building, and we reduced that to only 30 minutes, which is very good. This came without without issues because we, like I mentioned, we have some limitation with the 2 gigabytes image, and right now, not all the embedded board support the PVM kernel, but that should be fixed in the. There's some pending work to fit that. So what is the new workflow for the CI? Everything starts with the user submitting the merge request in GitLab, and that triggered the run in the runner and GitLab runner, running this new server we have with 160 cores, which is a new way to test ARM to ARM. So there is no cross building right now. Everything is native, which is a good advantage. And also that was one of the reasons is running very fast. And also, when the build is completed, we made it a skeleton to reconstruct all the lava definition for one template, which that fits several duplicated lava definition we had before. So from the one template, it recreates all the lava definition for per board, and that also help a lot to add new tests because just need to change one file or two, and that's it. And all the tests are very similar to in all the boards, in all the devices. So after that, everything is built and submitted to Lava. The board automatically runs on EFI shell using from ADK2. And this is, well, in building from F5, everything is signed because we run secure boot. So the second part, the F5 shell, is where the most of the tests run. We still are in the firmware. And here where is the most application run castle update to validate castle updates, secure boot, measure boot, and when they finish all running the test, it boots the OS from the network using a feature from U-boot using HTTP. And here is reboot the board. And remember, all this is running on RAM. And after reboots, is automatically download the OS with using a very good feature from EFI HTTP that was recently added last year. And with the new feature, the PBAM support, so it can boot from the RAM. and run everything on the RAM. And when they finish, it boot the OS, it runs, it finishes running the Yocto OEQ test. So this is the new diagram. This is the new flow where it's playing. You can see here, you start with the developer making the merge request to GitLab, and then it sends the build request to GitLab runner. The build completes. All the results are parsed by GitLab. And submitted then the jobs to Lava. And after submitting the Lava, the test to Lava, is start pulling on Lava to waiting for the test to finish, and then finish publishing the result to GitLab page, which is also something new we added. This is when the image is submitted to Lava. This is a diagram explaining how the test is run inside of Lava. You can see start with Lava, starting the device or the bar. From there, it download the firmware and the EFI firmware and the OS. Configure the image in the container when interacting with the Lava dispatcher, and then flash the image, only the firmware image, and then boots to U-boots, and from U-boots to ADQ2, then it runs the test, finish running the test, and download and boot the OS. And at the end, it gets to the prompt of the OS, running the OS test. This is, for me, is a very good diagram because it can introduce you how the test normally run on Lava. This is a new way to present the test result from the user perspective, because this is a screenshot from GitLab, when you can see straight away the result. You know, the difference with the previous CI is you had to get into the logs and then read the logs and find out the links and see the test results to see why it failed, for example. But then now you can see the straight away the results and why it fails. So that is a good thing. And also we did the new way to report the test results, when you can see all the boards and all the devices running or used to we are using to boot, like the KB260, the ACQ102, the Qualcomm board is a new board where being tested. Okay. So this and this is a new diagram. We show the boot time by stages, the download time, the kernel, and the part on the user space, and then we share some learnings from this experience, like how find out the documentation, and GitLab has needs some more work. How important is to use the needs keyword to improve the testing and the pipeline times. also how to improve the CI development time using the pre-commit tool, so we can check the 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 configuration before reaching GitLab, and also some advice how to avoid using things that like bashing, because everything inside of GitLab pipeline run on POSIX shell, and also how to debug things on GitLab. We also changed from repo tool to use CAS tools. One of the good features from CAS was is use CAS container, because it can replicate the same build configuration between boards, between environments, and also you can avoid install everything by putting everything on Lava. Sorry, in container image. And also some issue was how to prevent issue with open layers, because sometimes they change the infrastructure without sending any notification. So so the new improvements that we want to do is to add more Linaro members boards to the U-Boot CI, run more distro, work around the 2 gigabytes limitation, extend the way to do the testing, also reduce more the CI pipelines time. These are the links if you care about more details, the documentation, the repo, the reporting that you said before, and the new Lava web page for reporting, and more details there. So thank you so much. Any question? No? Okay, that's it. Thank you.